Hey, what's going on, everybody? It's the original gamer Stevie Stroh, and we are back for yet another exciting chapter on programming in BASIC with the Tandy Color Computer. This is an updated video on the most recent programming in BASIC video I did, where I covered chapter 23, and I covered how to use the set and reset command and how to use the joystick command. And I came up with a couple of demos that I thought were kind of cool, but after making them I was thinking to myself, you know what, I can probably do just a little bit better on these little demos. Even though they had a real simple purpose, their purpose was to illustrate the concept, I thought I could do a slightly better job illustrating them. And I just wanted to try out a few things, and I wanted to show you the most recent updates to these demos. And I want to let you know too that I do have a blog post that has a link to the disk image, so if you want to download this disk image and look at these two, I'll put a link to that blog post in this video when I'm done. So let's take a look at the most recent demos and what I did to them. So one of the first things I did is I updated the joy print command. Now, which is now called joy print 2. Now, what the original joy print did was it was an enhancement over what the book gave us. The book gave us the ability to hold on, let me grab my joystick, which is down here. Yeah, you just gotta love it, right? You just gotta love being professional and organized when you go to do a video, right? So yeah, so the original demo had all the numbers on the top of the screen, so no matter where you moved the stick, the numbers were always in one place. And so seeing the numbers change was kind of helpful, kind of visual, but I decided to make it where if I move the joystick, the numbers move with the joystick too. So as I move from left and right, you see that the number here is changing. If I'm in the far left, the number says 0. As I move to the right, the number gets bigger. As I move up and down here, this number here, if it's in the middle, it's 32. If I move it to the bottom, it's, you know, roughly 63. Okay, so there's my X and Y coordinates. Now, the first time I did this, I only did it with one stick, but I said, you know what? Let's not be completely lazy. So now I can move two sticks. And so now I'm moving left and right stick. So the left stick I'll move to the far left. The right stick I'll move to the far right, and you can see here that they're moving. So when I press the left button, I get the sounds on the right button, and when I press the left button, I get it over there, right? So now as I move this around, I can see that I'm pressing the right button, and as I move this guy around here, I can see that I'm pressing the left button. And there you have it. So the Joy Print program has been updated now just ever so slightly to actually include the ability to read from both joysticks and to be able to print those off. And so the actual program, not that big either. And I just added two whole sets of variables now. So now I'm reading X and Y for the first joystick, and I'm reading H and V for the second joystick. I'm doing a little bit of crazy math here where I have to take the X and divide it by 2 because the X number is between 0 and 63, which gives me 64 options, but my text is only got 32 options, so I have to divide X by 2 to get my 32 text locations. And then printing in wherever X was, the X position, I'm going to print out the value of X. Then I have a Y position where I take the joystick values and I divide them by 4, because the joystick goes up to 64, but there's only 16 lines, and so 16 is 1/4 of 64. So I divide those by 4 and I get a relative position for my Y axis, and I got my Y and my V. So I've got my X and Y and H and V for my two sticks. And then I print at the locations where these numbers are. I then peek for the joystick and then see, well, if I press the left button, I will print, or right button, I'll print RB, I'll make a sound. And then I print the next coordinates for my H and my V, which is the second joystick. And if I press the other one, I'll make that sound. So the actual program, very small, very simple program. But rather than the numbers always being on one line of the screen and never changing positions, I added the ability to visually see where you're moving your numbers around, just because Coco, right? So that was the first one that I enhanced. The second one I enhanced was Joy Paint. And I now have Joy Paint 2. And what is the main thing I did to Joy Paint 2? Well, I fixed the fact that I can now move my cursor around and not erase the screen. If you recall, I mentioned before I was doing a really cheesy, hacky way to set and reset a pixel to give me the illusion of this flashing cursor, and it was a very destructive way to do a non-destructive thing. And so as I'm moving my cursor around, I'm actually erasing pixels that I didn't want to erase. So right now I can move anywhere, and so I'm basically kind of moving my brush around the canvas. So let's go over here and let's pick a color. So if I pick color 1 for green, you can see here now I'm coloring in green. And now let's say I don't want to color anymore and I want to pick up my brush. I will press 9. When I press 9, the color goes back to 0. Remember, our colors are between 1 through 8. And so there is no color 9. So I'm using the color 9 to say, okay, change the color to 0. If the color is 0, I'm not going to paint anything. And now you can see here, if I move my cursor over these pixels, it's completely non-destructive. So I can move my cursor around here and pick a new position. So that was color 1. Now let's turn on color 2. When I press 2, you see that C equals 2 up there. And now I can paint around here, and now I'm painting in yellow, right? So I've just changed colors. I've moved to a different part of my screen. Let's press 9. I'm no longer painting. I'm going to move down here. I'll move over here to the right, and I'll turn on color 3. Color 3 is blue. Let's just paint a little bit of crap over here in blue. All right, and that's beautiful. You're blue, you're beautiful. Let's press 9. Let's go to color 4, which is red. Okay, so over here now, I'm coloring in red. There's my beautiful red. We'll press 9, we'll stop coloring. Color number 5 is white, right? So we'll press 5, and now we are white. Now I'll color in something in white, and oh my goodness, that is absolutely gorgeous. Now I'll move over here. I'll come down here. I'll go to color 6, which is the cyan. Oh my God, that is beautiful. Okay, we'll go to 9. We'll get rid of that. We'll go to color 7, which is magenta. Alright, we'll press 7, and look at all this magenta beautifulness. Okay, and then last but not least, we'll go to color 8, which is orange. Here's my orange, and now I'm just coloring that in, and now I'll press 9 again to stop coloring. And now you can see here, I can move my joystick around anywhere. I have a non-destructive cursive now that's basically an inverse asterisk. And anywhere I want to start painting, I just move the cursor to that location. I will press the button, and then I can start painting in that location. So it's just a slightly improved version over the book's demonstration, and it's illustrating the two topics that we've learned in here, which are X and Y coordinates for the set command and reading X and Y values from your joystick. The one thing I also did not implement that I was thinking of, but I was feeling like, okay, I want to make these a little bit better, but there is a fine line between going overboard and over the top when it's not needed. So the other feature I was thinking about adding was only painting when you press the fire button. And that would just cause me to have to peek in that value, and then only if the value equaled the buttons being pressed would I actually do the painting. So it would be just another couple more checks, a little bit of logic. It wouldn't be that hard to implement. But I am not trying to write a painting program. I want to eventually get into writing games. So I think this is good enough. The one thing I do want to spend a minute showing you how I did and explaining to you what I did is you might be saying to yourself right now, self, how does Steve move that flashing little asterisk there? That is cool the way it blinks. It's cool the way it moves. And it's even cooler by the fact that it is completely non-destructive. It does not damage or erase the background. Steve, how did you do it? Well, I'll show you. And of course, there might be two people who are saying that to themselves, because anybody who actually knows how to program knows exactly what I did. But let me show you anyways. So here's my program, and this program is so small. It's a small little program. It is, let's list 0 through 30. It's amazing what you can do in just a little tiny bit of code. All right, so first we clear the screen to all black. The main loop starts on line 10 where we read in our joystick. We read in joystick 0, joystick 1. I also make sure that the y-axis or the vertical axis doesn't go beneath 2, because 0 and 1 are the first 2 pixels, and that takes up that first line of text. So I don't want me going into those first 2 lines of text, because that's where I'm printing the information on the screen. And I also want to make sure that I don't go down too far, because the joystick value can actually go to 63, but my screen ends at 31. So I'm basically saying if you're more than 31, you're only going to be 31. You're not going to be more than that. And so that's where I start reading the sticks. Now, what else am I doing here? Now I'm getting a relative x and a relative y position here. So the relative x is how I'm calculating my text location on the screen for my cursor, because that cursor is actually a text character. So my relative x value is basically x divided by 2, because remember, your x coordinates are 64 pixels, but we only have 32 columns. So I get the relative x. I make it an integer, so it's not a 0.5. So if it was an odd number, it's not going to be like 0.5, it's got to be an even number. And then I get the relative y position, which is half of that. And the y gives me 63 values, but I cut that in half down to 32. And that's helping me figure out where things are. This is now where I'm doing my scanning for the key. And if I press a key, this is where I change my colors by reading the value. That hasn't changed. I print this one here. I'm actually printing at location 0. This is how one of the original joystick demos was working. When you moved your joystick around, it just printed it in one line. And for the sake of painting, I didn't want to have numbers all over the screen. So this is here as a reference, just to help you visualize and illustrate the concept of when you move your joystick, your x and y coordinates will change. Visualizing what those numbers are, and this is also visualizing telling you the letter C and showing you the number for what color you're using. Here is the magic of how I create my non-disruptive cursive. So the SL stands for screen location. So I start off at position 1024. Position 1024 is actually right here where the letter L is in memory. So my screen location, everything that your computer does is somewhere in its memory, somewhere in RAM. And every byte of RAM has got a number or a location that we can address. And the screen location happens to start off at exactly 1024. Basically it's the second K of memory. From 0 to 1023 is the first K. From 1024 to 2047 would be the second K or second kilobyte of RAM. So the first space on my character starts at position 1024. So I'm going to start here. I'm going to add the relative x, which is how many characters over, and then I'm going to take y, but I have to multiply y by 32, because every time I'm coming down one, I have to add 32 to go down one line, because there's 32 columns across. So for me to go from where this 40 is to the 50 is, I have to go down 32 bytes or 32 characters on the screen. So I start with position 1024, I add my relative x coordinate, I take my relative y times 32, and that comes, all these numbers added up come to SL or screen location. I then take this SD, which is the peaking of that. So that's the screen data. What is currently on my screen? I'll stick that into a variable called SD. So I figure out where I am on the screen location textually. I have to convert my graphical pixel coordinates into text coordinates. I then take a peek of that, and I'm basically grabbing whatever information is in this location. I'm then poking at this screen location a character of ASCII value 42, which happens to be the character that is the inversed asterisk. Now, because the flashing was so fast I couldn't even see it, I had to go sub a brief routine here that delayed for the count of 30. So I'm going from 0 to 29, I'm doing a slight delay that allows the asterisk to be on screen briefly, and then I just poke back the original screen data, what it was ever there before. This is similar to the get and put, right? So you're pulling what was there, you're getting that, I'm putting something else on the screen, and then I put back the background that was there. And then I just go back to the main loop where I'm reading the coordinates. And so it's a simple little program, but it's kind of a neat trick. And because this chapter already introduced us to peeking, and it introduced us to peeking the joystick value to get the joystick buttons, I decided to go ahead and peek the screen and use this to make the non-disruptive cursor that I really wanted to make. This is the cursor that I believe anybody who wants to make a cursor would probably want to make something like this, where you can move the cursor around, you can do all this fancy crap here, and then when you stop moving the cursor, you'll see that wherever the cursor goes, it blinks, but it also doesn't erase the background. Cool little trick. I like it. I hope you like it. It's a short, simple program, but it's really, to me, if I can see it, I can understand it. I'm the kind of person where if you can draw me a picture to explain me a concept, I can understand that concept. So I'm trying to draw some pictures here. I'm trying to give you some visual examples of what the whole idea of X and Y coordinates translate to your screen, and how colors translate to that, and how reading the joystick value and peeking and poking work. So last thing I'll show you as well before I end this video here is one of the original demos I also made was called the random set. So when you do random set, this is the one that put colors on the screen, and it picks a random X and Y coordinate and a random color, and it sets that coordinate with that color. Simple, right? Now, according to the book says you can set your color anywhere between 0 and 8. And so the book is leading us to believe we can set the color 0. I did some experimentation and I found out that that's just not the case, and I'll show you why right now. So if I change line 20 to say like CLS 8, which is orange, and I set an orange background, and in this case here, if I get rid of line 30 and I don't pick a random color, alright, I'm just going to pick my X and Y coordinates, and on line 40, if I say don't set color C, which was a random variable, set color 0, which is black. What is this program saying right now? Make the screen orange, pick your X and Y coordinates, and then set these X and Y coordinates at color 0. According to the book, we can do this, but when you run this program, what you will see is there are no black pixels here. We literally cannot set color 0. Now in the high resolution screen, I think you can. I think you can actually preset color 0, but there's also a preset that resets it. So even though the book says you can set a color anywhere between 0 and 8, setting 0 doesn't work. And I was curious about that, and I wanted to prove that it couldn't do it. I just proved it. So what did I do? I wrote an equivalent program to my random set that sets random colors, and I made one that was called random reset. And so if I do random reset and I run it, what this is doing here is it's picking a random background color and setting that color. It's picking your random X and Y coordinates, and actually in line 35 here, I don't even need to print C because C doesn't exist. Alright, let's resave this. Okay, although this is not going to be what's on my blog because I've already uploaded this to my blog. Alright, but next time I blog, you'll get this one. So now when I run this, now you are seeing that you can put black on here, and this is kind of cool, black and orange, very Halloweeny, very pumpkiny. But yeah, the only way to put a black pixel is to use the reset command, contrary to what the book would have us believe. So we can reset a black pixel, or we can set a colored pixel in one of the available 8 foreground colors. So that's it. So these were just a couple of things that were weighing on my mind, on things I wanted to improve. Not because anybody cares, only because I care. And so I just figured I started something, I did it kind of okay. I wanted to do it just a little bit better. And yeah, just a reminder, there is now a blog post for chapter 23 on my website, ogstevestro.com. And if you want to download this disk image with these updated demos, they are there. So I hope you enjoyed this. I look forward to recording chapter 24, hopefully tomorrow, where we're going to get into the play command and learn how to do better music, better than using the sound command. And so that's it. This is just a update to chapter 23, was it? I think, yeah. About having using the set, the reset, the point command, and the joystick command. I hope you enjoyed it. I'm the original gamer, Stevie Stroh. If you cannot get enough Coco, visit my website, ogsteviestroh.com. I've got links to all kinds of cool color computer stuff, like the Facebook page and the mailing list and the Glenside Color Computer Club and other people's blog sites and project sites and the Coco Crew podcast and how to get emulators and where to go to get software and the Color Computer Archive and you name it. So if you want a one-stop shop on where to find links for all things Coco, go to my website, ogsteviestroh.com, and while you're there, you might even want to check out the merchandise link and possibly grab yourself one of my DVDs, or grab a cool t-shirt that says I'm a Coco Nut, or anything else. They got retro merchandise, t-shirts, coffee mugs, DVDs, all kinds of stuff on my website. Show your support. If you like, go out there and grab yourself something cool. And that's it, guys. I'm the original gamer, Stevie Stroh. Keep on programming. Keep on doing your thing in BASIC. Coco forever. Peace out. Bye-bye. We'll see you on the next video.
Hello, my name is Grant Liddy, and I watch the original gamer, Stevie Stroh.
Hey, what's going on, everybody? It's me. It's Original Stroh's... It's Original Stroh? Yeah, okay. Let's try that again. Boop.